been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, this is 4.4, proving triangles are congruent by side angle side, or SAS, and also by HL, which stands for hypotenuse leg. So the first postulate is the side angle side postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So the important thing here is understanding what is meant by the included angle. So if AC is congruent to ZX and BA is congruent to YX, we see that when I trace those sides then create an angle. And that angle is the included angle. And so that's what needs to be congruent. So if angle C is congruent to angle Z, that's fine. But without knowing angle A and X are congruent, that is not going to be enough information for us to prove that these triangles are congruent. So that angle has to be the included angle, the angle that is formed from the sides that are congruent. So we're going to do a proof to show this. So given that BC is congruent to DA, so BC is congruent to DA, and that BC is parallel to AD, so this is how we mark parallel. So if that's parallel, then that means we have a transversal here. So this is our transversal. And we know some theorems about parallel lines cut by a transversal. So we're probably going to need to use that. So if I'm trying to prove this by side angle side, I need two sides congruent, and I also need the included angle. I already have one side, and that's BC and DA. I need an angle, and I need another side. Let me go ahead and write my given. So my given gives me the first side. So like I said, I need an angle and a side. So when looking at this picture, I see if we're trying to prove that ABC is congruent to CDA, I notice that both of those triangles have a C and an A, as you can see here. And so we see that that side is shared. So I'm going to write it like this. I'm going to say AC for the first triangle. AC is congruent to CA, and that is the reflexive property. So that is my other side now, AC and CA. So now I need the included side. So let me highlight in a different color the sides that I have. I need the included angle, sorry. So I have BC and AD, and then I have this. Okay, so my included angle is here and here. So are those angles congruent? Angle BCA and angle CAD. Well, again, if that green line is my transversal and BC is parallel to AD, then those would be alternate interior angles and they would be congruent. So angle BCA is congruent to angle CAD, and that is by the alternate interior angles theorem. And the reason that's the theorem and not the converse is because our if statement is if the lines are parallel, then the angles are congruent. The converse is if the angles are congruent, then the lines are parallel. All right, so now we have our angle, and that's BCA and CAD. All right, so now we have a side, an angle, and a side. Now we can say that the triangles are congruent. We just want to make sure that we've lined up the correct parts. So triangle ABC is congruent to triangle CDA. So remember, this means that AB should go with CD. Is that true? Does AB go with CD? Yes, it does. So that's just kind of one way to check to see if we wrote that correctly. And so that is because of the side angle side congruence postulate, but just putting SAS will be enough. We have another, this one is actually a theorem here in order to prove two triangles are congruent. So the hypotenuse leg congruence theorem says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. Notice it doesn't say a specific leg, okay? Either leg would be fine. So there has to be a leg congruent like there is here. This leg is congruent to this leg, and then the hypotenuse is congruent to the other hypotenuse. And again, this is only in a right triangle. So if you'll notice, the kind of the relationship here is that we have a side, and an angle, okay? Side, angle. So side, angle does not normally work. It only works for right triangles. So just keep that in mind. Don't try to use SSA in your proof if you're trying to prove that triangles are congruent, because that's not a legitimate way to show that triangles are congruent.